Hey everyone. Hi. Welcome. Yeah, thanks for joining. This is ESIP Cloud Native Geospatial Talks. So we're going to be doing a new format today. Thank you everybody for joining us in this exercise. So previously we've had like talks just serially one after the other, like 10-minute sort of talks before. And that's always been really awesome. But recently I went to AGU and the e-lightning format where people give basically pitches and then have people break out into sessions where they can like really talk to the experts and ask targeted questions was like I got the most out of that format as any just like listening to people talk for 90 minutes. So I thought I'd try it here. So I appreciate you guys trying this out with me. The way that this is going to work is we're gathering and reducing the structure. That's what I'm doing right now. We're going to do our elevator pitches for breakout talks and discussions. And then we're going to have everybody navigate to their speaker that they want to talk more to and hear more from. They're going to find that person in the room, and then everybody's going to go with their breakout group to the plenary room and sit around those round tables to have a deep dive into that presentation, that discussion topic. So we're going to do that for about 30 minutes, and then there's going to be an optional regroup. So if there was another topic that you're interested in, you will have time to switch tables and dive more into a different topic. Any questions about that format so far? Does that seem reasonable? So we go away for 30 minutes. No, good question. Nope. We're going to have Emma, who is my new colleague at Development Seed, right over there. Yep. Emma's going to give you guys an announcement at the sort of halfway mark for you guys to just regroup within that room, within the plenary room. In here, we're going to be supporting our virtual participants by having the first topic, which is the Cloud Native Geospatial Standards, that Michelle and I are going to be leading that discussion and breakout group. So if you're in this room, we're just going to continue the discussion. I will try and pay attention to time and say, hey, now is the time to go downstairs if you want to talk with one of the breakout groups from this group. Of course, if any of the groups have relatively low attendance, they're welcome to merge with another group. Sound good? All right, sweet. All right, so the first topic is mine and Michelle's topic, which is about cloud optimized data formats and standards. So we're going to be talking and asking some questions about what makes cloud optimized data so challenging and what are the different approaches for cloud optimized data and formats and data access. And basically, so I'm not actually timing myself right now. I just realized I should be timing myself. But so there's this really cool study put out, Task 51, which if you see this table here at the bottom left, they basically looked at a number of different sort of types of data that you could have. So they identified how certain data formats are really good at addressing different types of geospatial data. So imagery, swath, trajectory, and they sort of rated them across these different, how they performed for these different data types. And so we're going to be talking about what are the different data formats that exist right now for supporting cloud optimized data access and why it's such a challenge, and also how it depends on the use case. The answer almost always ends up being it really depends on the use case. So we're going to be going over some of those formats, in a presentation. And then we're going to be having these discussion topics and questions. So what does cloud native geospatial mean to you? Why does a common definition matter? We're going to be doing the landscape of cloud optimized data formats. We're going to deep dive into one or more of the cloud optimized formats gaining popularity. Is it COG versus R, or are they complementary? For example, it's a very interesting topic. I'm going to talk about some use cases. So if you have a use case where you really want to figure out what is the cloud optimized data format or data service that might satisfy your use case, I'd love to hear about those. And what are the challenges or needs do you have to moving to cloud native workflows? So those are our discussion topics and questions. Sweet. And so with that, I'm going to pass it off to Matt.
Thank you, Amy. Hello, everybody. My name is Matt Hansen. I'm with Element 84, and today I am here to talk about Stack. There's a bunch of different things that I could potentially talk about. I have several presentations I could walk through. I could talk about the current state and the future of Stack, the changes that are coming. I also have a presentation on public data sets available on AWS. So I could talk about some of the new data sets that we've indexed through and made available through EarthSearch, Sentinel-2, Landsat, NAPE, and Sentinel-1, and the various intricacies involved with those data sets. Or I could talk about the public data sets available on the planetary computer through NASA CMR, or the Landsat data available through the Landsat USGS Landsat Look API, which is also a Stack API. We could talk about the Python data ecosystem, so walking through how to search one of these endpoints with PyStack client, and then take that, save those items, and possibly download assets with the Stack asset library, or do analysis in place by using Open Data Cube Stack, ODC Stack, to open that up with X-Ray and use a Dask backend to process that data. I could talk a little bit about the JavaScript ecosystem, though not very well because I don't know much JavaScript. So notice that I wouldn't actually be able to talk about how to use it, but I could talk about what the latest advances are and what's available out there in that. Or if you have your own data and you want to stackify it, we could talk about how best to model that in a Stack item. It's not always really super straightforward to just be like, oh, I'm just going to create a Stack item. When we ingest data like into Planetary Computer or AWS, we use the Stack Tools packages, and there's a lot of decisions that have to go through. We like to make rich metadata and try to capture as much as we can. So if you have some data, we could talk through about modeling a Stack item or collection for it, and even make a custom Stack extension if that's something that you need. Or we could talk about how Stack is not used just for discovery anymore. Stack was primarily really presented as a way to discover data. However, we're seeing more and more extensions that are really around the use of the data. So things that describe the data types and the array sizes, these are useful when you're actually using the data. And recently on the Stack meeting yesterday, we talked about authentication. So like what we're after here is the Stack metadata should really capture everything that you need to know, or a client needs to know, about how to access that data, not just being able to find it, but then how do I actually access these assets. And because it came up today, I added this last bullet. It came up in the plenary this morning, is data provenance. There are things that we can do in Stack to track data provenance, but really would be interested in talking about that more with people, about maybe what's missing, and maybe what possibly could be added to Stack. And that's over 3 minutes. All right.
Thanks, Matt.
Thank you.
You can clap.
Okay. Hi, everyone. I'm up next. So I'm Brianna Pagan. I'm at NASA Just Desk, and I'm going to be hosting a breakout session on just GeoZar as a steering working group. So we recently submitted officially last week an OGC charter to get GeoZar approved. Yay. So I'm going to start the session speaking about just what is ZAR. I think there's a ton of misconceptions of what people think it is and what it's not, and then how it relates to GeoZar. So ZAR itself is this hackable data format, but there was a realization that we need extra extensions and things like that to make it work for geospatial software, hence the genesis of GeoZar. But in those conversations, we've had a ton of debates internally. One of those is the question a ZAR versus a COG, or are we actually realizing that ZAR is more conceptually aligned with Stack, especially hearing like new developments coming out with Stack in using ZARs as actually cataloging and searching for data. Why do we need a steering working group and an OGC bureaucratic process? Why now? That's because more and more users are demanding the use of czar, and there isn't a consensus yet on how a lot of these technical questions are going to be implemented. So it's actually very timely and urgent thing that we want to try to address. In our early conversations too, we've seen this sort of meeting of two very distinct worlds. NetCDF and GeoTIFF worlds have now combined and starting to come at the table, and GeoZar has been the center of this, and it's been very fascinating because we're not sure if this is like a meeting or a fight, and we would like to settle that in a steering working group. And also seeing like maybe what has been missed out of prior conventions, like a CF convention, and bringing in geospatial metadata into some CF conventions. Last thing is I'm going to try to rally people to get involved. Anyone who's using or a data producer, this is really relevant for you, and it's the year of open science, and there's just a ton of technical open work for you to join and help out with both czar world and getting GeoZar kicked off. So yeah, thanks.
So I don't think we have Ramon unless I missed him. Okay, cool. Let's go to Chris.
Hi there, I'm Chris Stoner. I'm with AWS. There's a lot of really good talks, so I suggest you go to more than one. This one will be a little bit different from the others. I'm part of the open data program, so we have 100 petabytes free and open to the public. And really, I wanted to focus the talk on how to use data that's free and open to the public. So I'll go through SageMaker Studio Lab, SageMaker Geospatial, which actually Matt mentioned a second ago, and LightSail for research, sort of what is the difference between them, when do you leverage them and how, a cost comparison, some are free, some are very expensive, some are in the middle. And then we can even do a couple of demos. I can show you how to light them up and what it would look like in your account. So that's the talk. Cool.
Next, we have James from 2ITC.
Hello there. So I'm from 2I2C. In terms of the group, there's a couple of things we could talk about. If you don't know what who 2I2C is, I'm happy to give you a presentation on what this nonprofit is. We build open infrastructure and manage it. The conversation I'd really like to have, though, is around building and supporting open science communities, specifically in cloud native geospatial communities and what that means. I've got a few slides on what we mean by open knowledge and open infrastructure and how we think interactive computing is an important part of that. I'd like to share with you what 2I2C's right to replicate. This is a principle of open science that we believe infrastructure should be created and hosted in a way that if and when you need to bring it back in-house or you need to migrate it to another platform or whatever, any part of the infrastructure that we work with you, you could just take it with you. It's sort of not just the software is open, but the infrastructure itself. I've got a little bit of a showcase on a brand new project in terms of inclusiveness on how we're delivering these open communities in the cloud space to Latin America and Africa. Generally, the question I'm looking for here that I would like to learn in the discussion is how we can better build and support open science communities and how they learn from each other. So just really briefly, while I have your attention in terms of who 2I2C is, what is this nonprofit? We sit the middle between open source ecosystems. A lot of our engineers are also core contributors to the Jupyter project, Jupyter Hub project. Everything we do, we upstream. And then we sort of do a support layer underneath that so that communities who want to use those type of tools don't necessarily need to build all that deep knowledge with a particular provider. So when we talk about well, I don't have the slide, it's not there anymore. We build this sort of infrastructure between them. Currently, it's Jupyter Hub. If you're interested in 2I2C or just building open science communities, I'd love to talk to you. Thank you.
I'm just going to share. Sorry, guys, we're just going to share the screen share real quick. Yes. Okay. Okay.
Thank you to our community fellow, Jake, for.
Yeah, can someone in the chat say whether they can see? Okay.
We're not so street like IT though, is that right?
Yeah, that is true, that is true.
Yeah, be worse at your job.
Can we see folks online? I'm just looking for, nope. Okay, great. Okay.
Thank you.
Mm-hmm.
Hey everyone, I'm Matt Rockland. I'm one of the lead developers of Dask. I work in a company called Coiled that helps deploy Dask. So if you're not familiar with Dask, very briefly, we do general purpose parallelism in Python. We work very well with libraries like Xarray to allow you to, for example, access this quarter petabyte data set and then process it in parallel. So Dask then takes your code and it splits across lots of different machines and run those computations nicely across lots of machines. Seems really pretty. It's a pain in the ass to set up, it turns out. As you try deploying distributed computing in the cloud, you'll note that it is hard. So a few years ago, many Dask developers went away and made a company. That company is called Coiled. And that company helps you to deploy Dask clusters from Python. That's how we started. Super easy, works in any AWS or GCP region, run it from anywhere, super responsive, handles lots of problems that we've seen in the real world. I'll move on. Coiled also helps you manage all of your cloud workflows with Dask. You can look at things like here, I'm looking at all these workloads that run historically. I can say, hey, this user had some issues, they got some memory issues. I can go and dive into their code. I can dive into performance. I can see all the challenges they've run into. I'm actually gonna skip ahead a little bit there, because when I talk to your crowd in particular, you all seem to care about constraining costs. And so we also do that. This seems to be like a big hot button issue for you all. So I noticed my colleague Patrick was spending a few $1,000s a day. I can go into Patrick's account and I can easily affect his constraints. So Coil provides a management layer on top of Dask. It's neat. So it's pretty easy to use. We found a very strange thing. We found that people were using Coiled to do non-Dask things. They were starting up like single Dask worker clusters and running one task. They're using this like a big heavyweight AWS Lambda. So they just wanted to like run a script on some region. They wanted data approximate computing that wasn't Dask. And so we've made lots of little APIs to help make that easy too. So if you want to use the cloud and it's a pain in the ass and you're using Python, we'll talk a bit about that. So that's it. That's what we'll talk about. So we'll be downstairs somewhere. Thanks everyone.
Next, we have Victoria from JPL.
Hey everyone, I work at Podak at JPL, and we've been working on a tutorial for using AWS Lambda to do science instead of just backend infrastructure. NASA's Earth data has all moved to the cloud, and that has opened up some new cloud computing capabilities. So I'm going to be talking about the architecture and all the different components that you need to set up to be able to use Lambda to do a science calculation on some of these large data sets that we are archiving at Podak. So yeah, that's the quick quick summary, but come find me downstairs.
Awesome. So last but not least, we have Diba Yavram. I hope I'm saying, okay, cool. From Palantir to talk about National Weather Model.
Hi, everyone. Nice to be here. It's my first year here, so thank you. Thank you. Yeah, my name is Diba. I work for a company called Palantir Technologies. If you've ever been on Reddit, you may have heard of it. We're essentially a data technology company that does a lot of data analytics end to end. There's a small team of us. So I worked at the EPA for like 6 years. I was on the hazardous waste space. I was trying to get complex data and make it usable for people. We're a small team at Palantir here that's trying to expand our sciences portfolio. We're just trying to learn more about the space and how we can kind of operate in there. We did a little pilot, taking just like giant chunks of the national water model data and then making stuff from it. We have an end-to-end pipeline that ingests data. You can manipulate it using Python, Pandas, PySpark, the whole deal, and then make applications from it. If you guys are interested in, bugging me, learning a bit more about how it works, I'm happy to demo it to you guys. Thank you.
Okay, cool. So everybody should go scan this now, I think, right? Okay, so this will be for the end or halfway mark. We'll ask you to please put in what breakout session did you attend and what is your key takeaway. I would also love it if you have enough people in your sort of breakout group for somebody to be assigned to be a note taker and for people to share notes afterwards. We always take notes during these sessions. And it's a really great way for us to know as a whole, cloud computing cluster, what was discussed and decided and what people's takeaways were. So yeah, please assign a note taker if you can. So at this time, I think I'm going to ask, actually one more thing. So I just want to plug the other cloud computing cluster sessions. So this afternoon at 4 p.m., we're going to have a tutorial session. So we're going to have Max Jones, who's in the room, and Raphael. They're going to be leading a Kerchunk tutorial. And then I and some of the others in the room, Michelle, Emma, and Victoria, are going to be doing a geospatial Python tutorial that's actually from the Carpentries. So it's also something you could go and do on your own. I'm sure the Kerchunk tutorial is available as well, but you want to do it here live, use this time. So that's going to be at 4 p.m. this afternoon. And then we also have a Cloud Native Geo Jam on Thursday morning, and that's going to be like open hackathon time or time to dive more into anything that you covered today or this afternoon. So you'll have some extra time on Thursday to dedicate to that. Awesome. Okay, cool. So now I'm going to have all of the speakers sort of go stand someplace around the room, and this is what we decided. Have everybody stand around the room, and I'll just point out their names again so you guys know, so you sort of have a reminder of who everybody is and what they're going to be talking about. Also, if you need motivation to go to the breakout, it's the same place where lunch is, so you have like first dibs on the lunch line. Just saying. I'm going to pretend I thought of that. Cool. So we have Victoria over here, who's going to talk about the PODAC workflows. And then we have Chris Stoner, who's going to talk about SageMaker. Brianna Pagan's going to talk about GeoZar. James Monroe, 2I2C, Matt Rockland, Dask and Coiled, DEBA, National Weather Model. Matt, we have with Stack, and did I miss anybody? Cool. All right, everybody find your speakers and go forth. And then you can rotate halfway through, yeah. And anybody who wants to stay in here and talk about the Cloud Native format, of course, you're welcome to do that.
Okay. All right.
Stack trains leave the building. You guys are here?
Yes.
So we're doing the.
I'm going to be doing our landscape presentation on different formats.
Interesting. The top.
And then we can Yeah, so if you're staying in this room, just like come to the front. Yeah, sure.
3 rows, no. If I can sit down, that would be great.
Yes, no, of course you can sit down.
I sprained my knee.
Oh no, what happened? How did you sprain your knee?
Is the ESIP summer thing, so last year I tried, this is my first time for the summer, ESIP. So before I joined last year, I was in right before, so I couldn't come. And this year, right before I came, I'm trying to pack and then I'm doing sort of go back. But I think this is a critical discussion.
Okay, yeah, that'd be great.
So basically, that's for the breakout room.
Oh, okay, like a separate room?
Yeah, so I don't know if you want this
Are we-
computer to join that.
Yeah,
Yeah.
like they want to be in this room, but in a breakout?
I think
Yeah.
it was,